great night. So it's Mr. Sander here, enjoying the nice weather from indoors because that's where I'm stuck. As you probably noticed, the seasons are slowly changing outside. Makes my cat really want to be outside, and me too. I really want to be out there. But we know what's actually happening. We know that the Earth is revolving around the sun, and the tilted axis is actually causing the sun's rays to hit the Earth more directly in the northern hemisphere. That's why it's so much warmer sitting in the sun right now than it would have been a few months ago. Okay, so here's my task for you. As you've probably, hopefully, never seen the TV show Game of Thrones. Because, geez, it's definitely not made for your age group. It's like definitely for adults. But there's a little weird quirk in that world. And that is, stop it. That is that the world that they live on doesn't experience regular period, like time frames between seasons. So they talk about things like having short summers, long winters, short summers. And that's because the length of them is never the same from year to year. So here's my challenge for you, is I want you to try and think about how could an astronomical body move in a way that allows it to have irregular seasons from one generation of humans to the other. It's kind of important to keep in mind that there is like recorded history in this universe, and in that recorded history, there is no sense of regularity. That doesn't mean that regularity doesn't happen on a time frame that is larger than humans experience, though. Okay, so to do this project, we need to really know about the revolutions and the rotations of planets and astronomical bodies. So let's think about Earth for a second. Earth revolves around the sun every 365.25 days. Now, here I wrote star because I'm not going to talk about the sun a little bit later, but for us, we know the sun is the star at the center of our solar system. So we know the Earth orbits or revolves around the sun once every 365.25 days. But the Earth's orbit, we also know, is pretty close to circular. It's not completely circular. It's a little bit elliptical. The other thing we know is that the Earth rotates on a tilted axis once one rotation every 24 hours. Oh, I can't even see that. Okay, so now let's think about this fictional planet that we've been talking about on which Game of Thrones is taking place. So this planet, we need to think about what variables we can actually manipulate. So obviously the variables of the time are able to be manipulated, right? You could change those up so that you have different year lengths or different day lengths. But there's other variables here that we may not have thought of. A planet doesn't need to have a circular orbit. What if a planet maybe had a more extreme elliptical orbit? And I drew it this way for a specific reason. First of all, you notice the distances from the sun aren't the same the whole time. And do you notice the distance on both sides are actually different? Maybe that's also a clue. But keep in mind, that would also adjust the way that you told time. And so you'd actually be able to use time to figure out when it would be based on the when you would have summer and when you would have winter. But what if maybe it went this way one year, and then all of a sudden this revolution shifted,
so that maybe it's a little bit different the next year. Okay, just a little clarification about orbital paths. I mentioned that the Earth's is fairly circular, and then I mentioned kind of irregular paths. I just wanted to give you a better demonstration of what that would look like. So let's say we have our body and it's orbiting around its own star. Don't ask me why I wrote stare. It's supposed to be star. There we go. Now, as it orbits, not all orbits look as neat and tidy as the Earth's does. Some will make an orbit, but then instead of getting back to its original starting position, it starts to orbit a little bit more like this. It's probably more similar to what you would see with like a comet's orbit, but a little bit more extreme. It's kind of like doing spirograph. Remember doing spirograph as a kid? You probably didn't even have spirograph like we did back in the day. Okay, but you can see doing something like that, you end up having like such irregularities. But really what you're looking for is like inconsistency in time, right? So hopefully that clarifies what I actually meant when I was talking about those different orbital paths. Not everyone is so circular like ours, which makes a huge difference in the way that something might orbit around a large body with a lot of gravity in space. Okay, thanks. Let's think about other variables. The tilt to the axis of Earth is always 23, well, pretty much always 23.5 degrees. But this tilt doesn't have to be the same every time. That could be a variable. And not only does it, could you change the amount of tilt? Let's think about some of the other things you could change. Maybe the tilt is different for a smaller time frame, and then it stretches. So let's think about like a top that's spinning. As a top spins, it eventually starts to wobble. And as it starts to wobble, maybe that wobble is actually happening to a planet as well. So keep in mind, motion is constant, but that doesn't mean that every oscillation or every movement is going to be the same from one time to the next. So these might be things that you want to keep in mind, variables you might want to play with as you try and solve this problem of inconsistent season lengths. Okay, so let's see what you can come up
with. Okay, so check out the attached sheet so that you can work through this and see if you can problem solve it. Don't just Google it, like use your brain, right? I know you're probably sitting on Google like 24 hours a day, but well, maybe 23, you gotta make your TikTok videos in between that. But see if this is a problem that you could solve. Okay, thanks.